Standard 2.1, evaluate all 6 trig functions using reference angles or the unit circle. So at this point, we've kind of let go of our unit circle, and we are moving on to just using our note card, which is basically this idea of using reference angles. So let's make sure that we can reproduce our note card without a lot of trouble, because by the end of this unit, you will not be able to use your note card when it comes to the test. 30 degrees in radians is pi over 6. 45 degrees in radians is pi over 4. And 60 degrees in radians is pi over 3. That pi looks kind of weird. I don't know what's going on here, but we'll try again. Okay. And we had a little trick that we learned in class for filling in the table here. Let's do 1, 2, 3, 3, 2, 1. All of these are over 2. And then the 2's and 3's in the numerators go under root signs. I mean, you could put the 1's under root signs as well, but the square root of 1 is just 1 anyway, so it's not really important. Tangent is y divided by x, or sine divided by cosine. And if we take sine and divide by cosine for 30 degrees, and we simplify, we eventually get root 3 over 3. And if we do the same for 45 degrees, take y divided by x, we get 1. And the same for 60 degrees, we get root 3. So you can choose to memorize the tangent column, or you can just do sine divided by cosine. All right, so now that we have our note card filled out, let's evaluate some trig functions at a given value. So example 1 here says find the sine of 5 pi over 3. There are 3 questions that you really want to ask yourself as you are evaluating these trig functions. The first question that you want to ask yourself is what value on the note card The second question that you want to ask yourself is, do I flip it? Whoops. And then the third question that you want to ask yourself is it positive or negative? Okay. So let's ask ourselves these questions as we are going through our examples. So our first example is sine of 5 pi over 3. And the first question we ask ourselves is what value are we going to use on the note card? As long as it's simplified, this over 3 tells us that we're going to be using the pi over 3 values, and because it's sine, we're going to be using root 3 over 2. So again, we're narrowing down to root 3 over 2 because it's the sine function, and then it's over 3. The next question is, do I flip it? So the answer to that would be no, because we're not looking for a reciprocal. If we were looking for cosecant, we would flip it. Or if we're looking for secant, we would flip cosine. Or if we're looking for cotangent, we would flip tangent. But sine is just sine, so we're not going to flip it. We're just going to take that value off the note card. And the last decision that we have to make is it positive or negative? And that's based on the quadrant that our angle is located in. So if we do a little sketch of our angle, 5 pi over 3 is in quadrant 4. And in quadrant 4, sine is negative, and so our answer is negative root 3 over 2. All right, let's do number 2 here. Again, the first question we want to ask ourselves is what value on the note card? So we're looking in the cosine column, and because this is over 4, we're looking in the over 4 row, and we're taking the value of root 2 over 2. The next question we ask ourselves is, do I flip it? Well, we're looking for cosine, not secant, so we're just going to take that value root 2 over 2. And the third question is it positive or negative? And so we want to sketch the angle. The angle itself is negative. That doesn't mean the trig value is going to be negative. But the angle, if you notice, is in quadrant 1. And in quadrant 1, cosine is positive, so our answer is positive root 2 over 2. If you need practice sketching angles, go back and view the video for standard 1.4. It explains how to do that. Example number 3 here, tangent of 540 degrees. So the first question is what value on the note card? And to answer that, we have to know if this is a 30, a 45, or a 60. How far is it away from the x-axis? Well, if we began sketching, we know a full rotation is 360. If we go another quarter of a rotation, that's 90 more, so that's 450. And if we go 90 more, that's at 540. So this particular angle lands exactly on the axis. And when we land on the axis, we want to use the coordinates for that point. This is a quadrantal angle. On the unit circle, the coordinates for that point are -1, 0. And now let's use a definition for tangent. Tangent is defined as y over x. So if we take our y value of 0 and divide by our x value of -1, 0 divided by -1 is actually 0. And so the tangent of 540 is 0 degrees. Suppose, just suppose, we were asked to do cotangent instead of tangent. So let's just think about what would happen there. Cotangent of the same angle. Again, because the angle lands on an axis, it's considered a quadrantal angle. We're going to use the definition for this function cotangent. Cotangent is defined as x over y. And in this particular example, if we take x and divide it by y, we get -1 divided by 0. And that is not defined. And so there's a difference when you're dividing by 0 versus when you're dividing into 0. When you're dividing by 0, if the 0 is in the denominator, your result will be undefined. If you're dividing into 0, meaning 0 is in the numerator, your result generally is 0. All right, let's take a look at example 4 here. So in example 4, again, the first thing we want to do is figure out what value we're going to use on the note card. Secant is the reciprocal of cosine. So we're going to go into the cosine column and use this over 6 to determine what row we're in. We're looking for cosine and over 6. Cosine over 6 is √3 over 2. So that's the value that we're going to use. The second question is, do I flip it? Well, since we're looking for secant rather than cosine, we need the reciprocal. So let's flip √3 over 2. When we flip √3 over 2, we get 2 over √3. And the third question is it positive or negative? So let's sketch the angle and decide what quadrant we're in. Okay. And since this is cosine, cosine's positive in quadrant 4, our value is going to be positive. Now you can leave it as 2 over √3, or you can rationalize it and get 2 √3 over 3. I will accept either of those answers. All right, continuing on to example 5. Now we're looking for cotangent. So cotangent is the reciprocal of tangent, and this over 3 gives us a hint as to where we're looking on the note card. So let's find the tangent column and the over 3 row. And we're going to be using the value of √3. Now the question is, do I flip it? Because cotangent is the reciprocal of tangent, the answer to that question is yes. So we're going to flip √3. And if we flip √3, imagine as √3 over as a 1, that becomes 1 over √3. So that's the value that we're going to use. Now we have to locate the angle to decide if it's positive or negative. So where is -13 pi over √3? That's not so easy to visualize. It might help to convert that number to a decimal or to an mixed number. So if we convert that to a mixed number, I believe it's -4 1/3 pi. Or if you convert it to a decimal, it's -4.3 repeating pi. So let's think about where that's located. Okay. It's negative, so we're going in the clockwise direction. One circle, that's 2 pi. Another circle, that's 2 more pi, so now we're at 4 pi. And then another third of a circle. And so if we go, or another third of a pi rather. So if we go a third more of a pi, we are here in quadrant 4. So in quadrant 4, again, if that's confusing, this is -4 pi, this is -5 pi, so we're in between -4 and -5, closer to -4. And so this is Quadrant 4, this is where tangent is negative, so our value is going to be negative. So it's negative 1 over root 3, or if we simplify that, just plain old negative root 3. Finally, our last example is cosecant of negative 150. Let's sketch that, and you can see that it's in quadrant 3, and the reference angle here is 30 degrees. That's the size of the angle, how far it is from the x-axis. So we're looking in the sine column, because cosecant is the reciprocal of sine, and we're looking in the 30 row. Sine of 30, if we go back, is 1/2. The next question is, do I flip it? And since we're looking for cosecant, that's the reciprocal of sine, the answer is yes, we're going to flip it. So we're going to have a trig value of 2. The final question is it positive or negative? Based on our sketch, our angle is located in quadrant 3, and sine is negative in quadrant 3, therefore our answer is negative 2.